Okay, folks, and for our last video from Chapter 2, we're going to talk about the idea of trade. And this extends our conversation about a given market participant's production possibility frontier. We recognize now that that PPF allows us to understand in scarcity how one market participant has to give up the opportunity to make one product in order to make the other product. And this leads to the concept of opportunity cost along that PPF. The idea that in order to choose one course of action, let's say make more trucks, given our PPF, we have to give up a certain amount of cars. And so that alternative that we give up becomes the opportunity cost of producing trucks. We're going to extend that conversation now into the realm of trade. And the only thing that changes here is we bring another participant into the marketplace. And we're going to analyze both participants to try and determine whether each market participant has any particular advantages that may allow us to better our position beyond what we could do given our own limited product possibility frontier. There's really two types of advantages we want to consider: absolute and comparative. Now, absolute advantage stems from the idea that for both participants, in our case, we're going to use Canada and the United States, they both have the same resources and same technology. So we're going to hold everything constant for both participants, and then we're going to plot their respective PPFs. And in our case, we're going to assume that, as we did before, the United States could take all their resources and make 60 cars, or take all their resources and make 100 trucks. Canada, on the other hand, if they took all their resources to make cars, could make 80. If they took all their resources to make trucks, they could make 80. So again, the resources are allocated entirely to one of the other products. And since we have the same resources or technology to work with, it suggests that if each country took all their resources and produced cars, Canada could produce more cars than the United States, 80 to 60. On the other hand, if both countries took resources and did only trucks, the United States would be superior, 100 trucks versus 80 for Canada. And what we've just described here is what we know as absolute advantage. And it suggests that when there are multiple participants in a market, that participant that can make more of a given product with the same amount of resources has an advantage in terms of total output. So absolute advantage, from a graphical standpoint, we can see represents where two market participants happen to have their intercepts for the two products in question, cars or trucks. And the one that can produce the most, the highest, with the same amount of resources, has an absolute advantage. Okay? Nothing crazy there. That seems pretty straightforward and pretty simple. Where it gets a little trickier, though, is when we begin to look at a second type of advantage in the marketplace. And this one really becomes critical for the analysis of trade, and it's what's known as comparative advantage. Comparative advantage. And what comparative advantage is going to ask is which country has to give up less of one product to produce the other. In other words, which one has an advantage in terms of opportunity cost in terms of producing one product versus the other. Now, you recall that we decided when we talked about trade-offs that the slope of a given PPF, in this case for Canada, represents how rapidly or at what rate Y changes, drops, as X increases. More trucks can only be made with limited resources if I choose to make fewer cars. And therefore the slope of that line represents the next available option, cars, that has to be given up in order to make trucks. That's what's known as opportunity cost, right? And we decided also that we could calculate that opportunity cost by calculating the slope, which we know is change in y over change in x. Okay? So, in terms of words, we can look at Canada and ask the question, what's the opportunity cost for Canada of making trucks? Well, the only cost we know is the opportunity cost that they give up in terms of giving up cars. And so, if in fact Canada chooses to make 80 trucks, the only way they can do that is if they give up making 80 cars. And so the slope for Canada in terms of making trucks is -1. At the very same time, if we look at the United States, they face the same dilemma, same resources, same products, trucks versus cars. The United States could indeed decide to make 100 trucks. But the only way they can do that is if they give up making 60 cars, which means the slope of their production possibility frontier, as we calculated before, is 0.6. Okay? For the United States, in order to make 100 trucks, they would have to give up making 60 cars. The cost of making trucks is giving up the next available option of cars. 100 trucks, 60 cars. Slope of that line, -0.6. That tells us, therefore, that when it comes to manufacturing trucks for both countries, for Canada to choose to make one truck, they have to give up one car. For the United States to manufacture one truck, they have to give up 0.6 cars. Or they give up less cars to make a truck than Canada does. Read another way, guys, in terms of opportunity cost. Since the United States opportunity cost, the slope of that line, is lower, that suggests that the United States pays or spends less in terms of cars to make trucks than does Canada. And if you think about it, when two companies are manufacturing a product, the one that manufactures it for lowest cost is going to have an advantage. Okay? Lowest slope, lowest opportunity cost, lowest cost, advantage relative to the other participant in the market. Or another way to say it, in comparison to Canada, the United States has lower opportunity cost of manufacturing trucks. Okay? Now, if we want to talk about the opportunity cost of cars, we have to do it a little bit different. Because when we're talking about making cars, we're now talking about moving this way. In order to do that, X has to change in that direction, right? So, when it comes time to decide what the opportunity cost is for cars, we have to do the inverse of this calculation. And we're going to see, therefore, that the opportunity cost of cars is the inverse of the slope. Graphically, it's going to be the change in X relative to Y. So what we're interested in, as we're going to change Y, make more cars, we're interested in how X is going to change because of that. And so therefore it's essentially going to be not change in Y over change in X, but change in X over change in Y. So if the United States chooses to make 60 trucks, 60 cars, in order to do that, they're going to have to give up 100 trucks, resulting in an inverse of the slope of 1.67. And again, since we're decreasing, it's going to be a negative slope. So that's going to be the opportunity cost of cars for the United States. If we look at Canada, by the very same token, in order to make the most cars they can, that's going to be 80, in order to make 80 cars, they're going to have to give up 80 trucks. And we can see the inverse of 1, of course, is 1. In this case, the lower number represents the lowest opportunity cost. For Canada, it costs them fewer cars to make a truck than the United States. Because for the United States, they have to spend 1.67 trucks to make a car. For Canada, it's only 1. And so, in comparison to the United States, it's cheaper for Canada to manufacture trucks. Excuse me, it costs them less, and therefore they have an advantage in comparison to the United States.